Okay, I'll get started here in just 1 second. Okay, this is Introduction to Linear Algebra, Section 1.1, and Section 1.1 is all about systems of linear equations. So an equation is called a linear equation if both sides of the equations are sums of constant multiples of the variables. So for example, those two equations that I wrote are linear equations. X plus 5y plus 3.2x equals 4, 3x1 plus 4x2 plus 3x plus 10x4 is equal to 8. Those are both examples of linear equations. The equations below are not linear. You've got x squared plus 1 equals y. That's not linear because of the x squared term. Xy plus xz plus y is equal to 5. That's not linear because of the xy term and the xz term, so those are variables being multiplied together. The variables can only be multiplied by constants or added together. And then finally, cosine x plus sine y is equal to 0. That's not linear because of the cosine and sine. Those are not linear functions. A system of linear equations is a collection of several linear equations. There's an example. So there are 3 linear equations there, and the main goal, or one of the main goals of this course, will be to solve systems of linear equations. So linear equations may have solutions, and a solution to a linear equation, those are just the numbers that make everything true at the same time. So for example, if you look down here, you've got x plus y equals 1. So if x were to equal 1 and y equal 0, that would be a solution to that first equation. And the solution to a system of linear equations makes all of the solutions, or makes all of the equations true at the same time. A solution set to a system is just the set of every solution. Linear systems of equations may or may not have solutions. A system that does not have any solutions is called inconsistent, and a system that does have solutions is called consistent. So hopefully those words kind of make sense with what your intuition would tell you. So for example, the equation below has no solutions because 2 things can't add up to equal 1 and 2 at the same time. Hopefully that's clear. And you will see later that consistent systems will either have exactly 1 solution or infinitely many solutions. So now we're going to actually practice solving a few systems of linear equations. So the first example is going to be x1 plus 5x2 equals 7, and negative 2x1 minus 7x2 is negative 5. And so to do this, we're going to construct what's called an augmented matrix. And that basically means we're going to ignore these variables and just worry about the constants that are in front of the variables or on their own. So the constant that's out in front of that first x1 is just a 1, and then we've got 5 and 7, and now negative 2, negative 7, negative 5. And then some people like to draw a line right here to remind you that that's like the augmented column. Some people just leave it without the line. I like to draw the line, so I'm going to put the line there. And then the rules for elimination is we can change the order of the rows, so we could switch these two rows around, and you can multiply any row by a constant, and you can add a multiple of another row to another row. So just to kind of run through this, so first, and the goal of this is to get the matrix into a form where it's really easy to read off the solutions, or at least easier than it is right now. So we're going to start by taking the second row and adding 2 copies of the first row, so that way we can make that -2 into a 0. So I'll say row 2 is equal to 2 row 1 plus row 2. And what we get, the first row doesn't change. And then the second row, I'll run through this with a bit of detail this time. We'll have 2 times 1 plus -2, and then we'll have 2 times 5, which is 10, plus -7, and then 2 times 7, which is 14, plus -5. And this is equal to 157, and then we'll have 0, -2 plus 2, +3, and +9. Okay, from here, there's a few things that you could do. You could go ahead and try to eliminate this 5 using the 3. I don't always like to do that because I can kind of turn this back into a system of equations now. I see that x1 plus 5x2 equals 7, and 3x2 is equal to 9. So I can then easily see that x2 is equal to 3, and then I can plug that back into the first equation. So x1 plus 5 times 3 is equal to 7, and so 15 equals, well, x1 plus 15 equals 7, and then we have x1 is equal to -8. So our solution is x1, x2, that is equal to -8, 3. And it's always a good idea to check your answer by plugging this back into the original equation, or both of the original equations. So we'll do that here really quickly. We've got -8 plus 5 times 3. Well, that is what we just saw. That's -8 plus 15. And this is definitely 7. And now for the second equation, we've got -2 times -8 minus 7 times 3. Okay, -2 times -8 is a +16, and then minus 7 times 3, that's 21. Well, that's -5, just like we expected. So this solution is correct. Another problem that you'll see kind of a lot, at least in this section, are problems like this one. So you've got 1H4, 3 6, 8. And it asks you to find which values of h make the solution or make the equation consistent, and which values of h make it inconsistent. So what we can do here is just do elimination as well. So we'll start by taking row 2 is equal to -3 row 1 plus row 2, and that'll give us the matrix 1h4. That doesn't change. I actually kind of want to make this a little larger. Okay, so 1h4, and then we'll have this will be 0, and then this will be 6 minus 3h, and then this last one will be, well, we've got 4 times 3 is 12, so minus 4. Okay, and at this point, I might put this back into a system of equations so we can kind of have a better picture of what's going on. So we'll have x plus, I'll say h times y is equal to 4, and we also have 3 minus, or 6 minus 3h, sorry, 3h times y is equal to -4. Okay, so since y can kind of be anything, the only time that we'll run into issues is if this right here were equal to 0, because then we would have 0 equals -4, right? As long as that isn't true, then we can find y just by dividing, and then we can plug in that value for h, and then we can make x whatever it wants, so, or whatever it needs to be to make that work. But if this is equal to 0, then well, 0 doesn't equal -4. So when 6 minus 3h is equal to 0, there's no solution. Or the system is inconsistent. And that, of course, happens when h equals 2. So when h equals 2, the equation is inconsistent, and then the equation, or the system of equations, have a solution for every h not equal to 2. So as long as h is not 2, we have a consistent system here. That will be all for this section.